All right, the last type of intermolecular forces is called London dispersion forces, and I just call it London forces. All right, so this type of interaction occur between nonpolar and nonpolar compounds. All right, I'll start right here. So we have neon, we have methane, and you guys know that an atom or molecules they have electrons floating around. All right, floating around atoms or molecules, and they distribute evenly throughout the molecules or an atom. Right? But let's say if there's an external factor outside that make this electron density migrates to another side, so look like this, right? This guy can form temporary dipole, small dipole, really small. It's just temporary, not like the previous cases, like in dipole or hydrogen bond. Those actually have a permanent dipole, but this guy doesn't really have dipole. But sometimes they can form a little, so we call just temporary dipole. All right, and this temporary dipole can induce just a normal regular atom or molecules for electron density to migrate to another side as well. Right, so this also the molecule next to it can form a temporary dipole as well, and that make partial negative, partial positive, they attract. This attraction is really weak. Look at the boiling point. I don't have to say anything. It's much weaker, right, compared to dipole or hydrogen bond. Okay, so that's a London forces. Now, the special thing about London forces, so the larger the molecule, so if you look at the molecular weight, so we have fluorine, chlorine, bromine, iodine. So we have 38 grams per mole all the way to 253.8 grams per mole. So iodine is really big compared to fluorine. All right. Basically, if you go down the group in the periodic table, the atoms or molecules are larger at the bottom. Okay. So when the molecular weight is higher, so the molecule is larger. Larger molecules have more electron density, right? The electron is denser because there's more electrons basically. And when this electron migrate to one side, right, the difference in in charges is higher, okay, compared to the small molecules. And when it's from London forces with another molecules, this guy's big, right? The attraction force is big. So if you still remember this equation, high charge, high attraction, high boiling point. Right? If you have to guess the boiling point, so look at the fluorine. So the small, the lowest boiling point here. Iodine, really high boiling point, even higher than water. And that's a special thing about London forces. Right? So it the attractions increases when the size or the molecular weight increases. Okay. Now, if I ask you to guess who has the highest boiling point here. Well, the one down here, because the largest, if you look at the molecular weight, so methane is real small, 16 grams per mole. But this guy, 1, 2, 3, 4, 5, 6, hexane, 86.18 grams per mole. The size is big in here. All right. So the size is bigger. Of course, it got more electrons, more space. All right. When all these electrons migrate to one side, the partial negative, partial positive is big. Okay. And higher attraction, basically. All right. So look like that. Compared to water, look at that. Right? Some of them can beat water because of high in London forces. All these are non-polar, like no dipole, no hydrogen bonding. But some of them can beat water if they have enough electron in the molecules. Okay. All right. So answer this real quick. So this cell fuel is made of hydrocarbon with an average of 13 carbon atoms per molecule. Gasoline is made of hydrocarbon as well, but in an average of 7 carbon atoms per molecule. Which fuel has a higher boiling point? Well, just draw it out then. So gasoline, 7 carbon per molecule, right? Diesel, 13 carbon per molecules. Of course, diesel is much bigger, right? The electron density gonna be higher in here. So higher surface, higher electron density. Well, higher boiling point, more electrons basically. Okay. All right. That's the London forces. We're going to close this video with anyone like Disney one more time. Okay. Let's take a look at some of the Disney that what happened when Disney get real. So I kind of like this, that the artist did it pretty well. If you have played Angry Birds, anyone have played Angry Birds? Yep. When it gets real. So oh, that's kind of, eyes, blood. We got Pocahontas. When Pocahontas get real, and then John Smith. Oh, poor John Smith. Pikachu, when Pikachu gets real. Not like the cute Pikachu anymore. We got Frozen. That's Elsa. Queen of Arendelle. Frozen. We got Lion King. Look like the Game of Thrones. Anyone have watched this show when it, like, I don't know, like, have you born yet? So this is a long time ago. So the Powerpuff Girls. So we got Little Mermaid. So when Ariel gets real. So that's look, ew. And we have, and this one's from anime, Sailor Moon. Anyone have watched Sailor Moon? Look like Miley Cyrus or somehow. Okay. All right.